Hi, I'm Richard Albans, the owner of TTS Performance. I'd like to talk to you today about the design process of fitting a supercharger to this new Triumph Rocket 3 2.5 motorcycle. This is fresh out the crate from Triumph. We've bedded it on the dyno, seen what it's producing as standard. We're pulling 150 horsepower, 150 foot-pound of torque. It's a great motor. We've supercharged the old Rocket 3, so when a client of mine asked me if we could supercharge the new one, I didn't think it was going to be too big a task. So this is the design processes that we've been through to try and come up with what's turned out to be a very unique and simple design, and it's going to make this bike even more awesome. My customer was asking for 300 horsepower. That should be achievable. But to achieve that, we need to push twice as much air in the engine as what it normally takes. That's a bar of boost or 14 pound of boost. To get that much air in the engine, we need Rotrex's C3094 supercharger. That's a really sweet unit. It's not too big, but we've still got to find somewhere to put it on this motorcycle. So we started analysing the motorcycle. We pulled it down, pulled the front off, pulled the front case off so that we could get to the crankshaft and see what was in the way and how we were going to achieve this goal. First thought was that we'd run the supercharger drive belt straight off a pulley off the end of the crank. This would be here, but in front of the crankshaft is the water pump. The water pump drive is this little baby here. Now this is only an 8mm thread, so one, the thread isn't man enough to drive a supercharger pulley. Two, the water pump's in the way. And three, we've discovered that the crankshaft rotates in a counterclockwise direction. This means that the supercharger, if it was sat on the bike this way around, over here or wherever, it would be running backwards. And this is unacceptable. Obviously, the supercharger is designed to rotate clockwise, and it wouldn't be blowing any boost if it was running counterclockwise. So we had to get over this problem. We've had several thoughts. We could run a double-sided belt and run the supercharger off the back of the belt. This would mean the supercharger would be pointing this direction, and this would put it in the way of the front wheel. It would collect all the road dirt. It would look atrocious, look like a wart on the end of the bike, and it wasn't acceptable. Another option would be to remove the catalytic converter on the exhaust, which sits here. The alternator is sat at the back. We could drive off the back of the alternator to the supercharger, but we've got some major chassis rails in the way, and this would all need a redesign. And then we've got a hideous problem of where do we put the air filter? How do we get the air from the supercharger up to the throttle bodies? And again, it was getting messy. So about 3 days in, I had a bit of a eureka moment and realised that there's a possibility of driving the supercharger off the clutch. The clutch is rotating in the opposite direction to the crank, so it's rotating in the right direction for operating the supercharger. The supercharger could be sat here, so it'd be a very simple drive, but the question is, how do we get the drive off it? And will the clutch actually rotate fast enough? So we had to take into consideration the primary drive ratio. Now the primary drive ratio has turned out not to be so far away from crank speed. It's only 80% of crank speed. So it's acceptable. With a big pulley on the end of the clutch, we can get a ratio so the supercharger is doing its job. But now we've got another issue. The clutch is operated from the front. The clutch slave cylinder pushes on the front pressure plate here, but we want a pulley here. So this takes a bit of thinking about, but we have come up with a solution. So firstly, I must say that these parts are prototype parts. The finished CAD designed sculptured pieces will look 1,000,000% better to the eye than what we have here. But this is to prove the concept and see if the parts will work ahead of the time of getting the production parts done. Okay, so this is the drive plate which sits on the clutch. So this sits there. The front clutch cover and water pump sit over the top. We have two monster bearings in here to hold the drive plate in place and stop it wobbling around. That comes through to the outside with an oil seal, and then we have a pulley that sits in there and bolts to the drive plate. That's straightforward enough. But now we have to operate the clutch. So there's the clutch slave cylinder. You see we have quite a diameter there. This is the reason for the big hole in the middle. This now fits over the top of the drive pulley and belt, and with a longer push rod we can now operate the clutch with no problem at all. And then with the supercharger here we have a nice simple belt arrangement and the job's done. Okay, so like I said previously, this is pure prototype, proof concept. Check the drive mechanism works, that we've got nothing to address before the production parts are made. So now we've got the supercharger in place, we've got the belt guard with the slave cylinder operating the clutch through the middle, belt tensioner all sweetly laid out and just looks like it needs to be there. We've made a prototype plenum chamber. Again, it won't look anything like this on the production, but it gives us the opportunity to start the bike, run it, and then work out what we're going to do with the engine management. And this is the next stage. Once we're up and running, we need to get enough fuel in it, get the air in it, see how much horsepower she makes.